Hello. This will be a demonstration of Proposition 10 from Book 8 of Euclid's Elements, which says that if numbers fall between each of two numbers and the unit in continued proportion or geometric progression, then however many numbers fall such between the unit and each of our two numbers, there will be as many numbers that fall between the two numbers also in a continued proportion. Again, this is kind of a confusing enunciation. It's a little wordy, but it'll gradually become more clear as we go through the proposition. You'll also, of course, notice that this is sort of a converse to the previous proposition, 8-9, except it doesn't involve two numbers that are prime to each other, but other than that, it's more or less a converse. We're given a unit C and two numbers A and B. Furthermore, we've established a continued proportion between the unit C and the number A, filled by the two numbers D and E, so that C, D, E, and A form a continued proportion. And likewise, between C and B, we've established another continued proportion filled by the numbers F and G, such that C, F, G, and B form another continued proportion. And what we want to prove is that as many numbers fall between the unit C and the number A or the number B in continued proportion, so many will also fall such between our numbers A and B, namely 2. Because you recognize that between C and A, there are two numbers that fall between them in this continued proportion. And likewise, between C and B, there are two numbers that fit in continued proportion between C and B. We're going to begin by creating a few numbers, H, K, and L. We're going to make H by taking the product of D and F. So D times F makes H, and likewise, we're going to take D times F again, that is going to make the number K, and D times H will make the number L. Oh, excuse me. D times H makes K, and F times H makes L. Sorry. A little confusing to read that, but yeah. So D times H makes K, and F times H makes L. Now, because the unit C is to the number D, just as the number D is to the number E, we were simply given that because C, D, and E are in a continued proportion, we can use proposition 719 to say that the product of the extremes is equal to the product of the means with this proportion. The extremes here are the unit C and the number E, and the mean are two copies of the number D. So we have that the unit C times the number E is equal to the number D times the number D. Well, the unit times any number is just that number. So the unit C times the number E is simply the number E itself, and the number D times the number D, that is obviously just D squared, so the number E is equal to D squared. Now we can go through a similar line of reasoning, establishing a proportion from our given continued proportions, and using proposition 719 to take some products, and what we'll end up saying is that the number A is equal to D times E, the number G is equal to F squared, and the number B is equal to F times G. Now, because the number D has been multiplied by the two numbers D and F to make other numbers, namely E and H, so remember we just proved in step 2 that D times D, or D squared, makes E, and we took the product of D and F at the outset in our first step, and we called that H, so D times D makes E, and D times F makes H. So we can say by proposition 717 that the numbers multiplied have the same ratio as the products, namely that D is to F just as E is to H. Now we can prove in a similar way that D is to F just as H is to G. So we have two ratios which are the same with the same ratio. A property of numbers tells us that they are the same with one another, so that we can say that E is to H just as H is to G. Next, because the number D has been multiplied by the two numbers E and H to make two products, namely A and K respectively, so remember D times E, we proved in step 3 that that makes A, and D times H, we did at the outset in our first step to make the number the number K. So D times E makes A, and D times H makes K. So we can say that, again, by proposition 7.17, that the numbers multiplied will have the same ratio as the products. We can say that E is to H just as A is to K. But you'll remember we had proved in step 4 that E is to H just as D is to F. So we can say by property of numbers, two ratios are the same, or you have two ratios which are the same with the same ratio, they're the same with one another, so that D is to F just as A is to K. Now again, in a similar way, we can prove that D is to F just as K is to L, so that again, we have two ratios which are the same with the same ratio. Property of numbers tells us they're the same with one another, so that A is to K just as K is to L. And what you hopefully immediately notice from this statement is that A, K, and L form a continued proportion because A is to K just as K is to L. Now next, because the number F has been multiplied by two numbers H and G to make two products K and B respectively, remember at the outset we made F times H, that makes K, and F times G, we had proved in step 3 that that makes B. So that we can say, again by proposition 7.17, that the two numbers multiplied have the same ratio as the products. We can say that H is to G just as K is to B. But you'll remember in step 5, we had proved that H is to G just as D is to F. So again, for the final time, we have two ratios which are the same with the same ratio property numbers. They're the same with one another. So that D is to F just as K is to B. And you'll notice that the three ratios, A to K, K to L, and L to B, are all the same with the same ratio, namely D to F. So by property of numbers, they're all the same with one another, so that A is to K, just as K is to L, just as L is to B. And again, what you'll immediately notice from this is that A, K, L, and B form a continued proportion between our two given numbers A and B. And furthermore, this continued proportion is filled by two numbers K and L, which is what we wanted to prove. We wanted to prove that between A and B, if we formed a continued proportion, there would be two numbers situated between them, and we've just proven that, so we're done with the proposition, therefore, etc., Q, E, D. I'm of course going to give a particular example of what this proposition would look like. So say we would have two continued proportions, 1 to 2 to 4 to 8. So we go from the unit to some number and form a continued proportion. And likewise, we can do that again, starting at 1, but instead going to 3, to 9, and to 27. So again, we've gone from the unit to some number to form a continued proportion. Then what this proposition 8.10 allows us to say is that were we to form a continued proportion with the ends as 8 and 27, or a continued proportion between 8 and 27, this will be occupied by two numbers, and this is obviously the case, because we can go from 8 to 12 to 18, right back to 27. And you notice that between 8 and 27, there are two numbers, namely 12 and 18, which fill out their continued proportion, which is the same number as we have between 1 and 8 and 1 and 27. So we see that this proposition holds. That's all I've got to say about this one, so I'll end the video here and move on to proposition 8.11.